Hello, another day, another vlog, Charet. We'll begin to run through with the Bellman Ford algorithm, my dear student. This is another shortest path technique, which is will definitely will definitely make sure to run through with negative value because the extras algorithm will not accept negative value. Suppose that we do have negative here, but what will be the steps for the Bellman Ford algorithm? You have to enumerate all of those adjacencies, all of those particular path that you can go. So there will be, you have to enumerate that. So there will be A to B. There will be A to E. Sort it out, okay? There will be A to F. And then after that one, that will be the adjacent. So we'll begin to check for B. What will be the adjacent of B? There will be BC. There will be B to F. Okay, that's our already done. From C, what will be the adjacent of C? Okay, C is having C to D alone. Then what about D? There will be D to G. And what about E? E is actually having two adjacent, which will be E to F and E to H. And then afterwards, aside from that, E to H, for your F right now, there will be adjacent of C, F to G, F to I, and F to J. And afterwards, you'll proceed with G, G to I, and after that, you proceed with H, H to F, then H to I, and there will be H to J. And afterwards, there will be I to J, and for J, there's no adjacent. So this is the enumerated list of particular data, or I mean the path that we'll begin to take as we go through with the process. Okay, so those are the flow that we'll begin to work on. So how can we work on this? You have to the same with you have to identify the node and A, B, C, D, E, F, G, H, I, J. The same particular steps, no significant differences between the Dijkstra's and the Bellman Ford. However, here we can it will accept actually a I mean the negative value. So right now we'll begin to follow the structures of this one, the directions that you do have. That's how you will work on. So suppose that everything will be um you will normalize, you will need to relax them. So it will be set into zero, the start state, and then everything will become um will be infinite, set to infinite. And we will check the adjacent. Okay, this is for this step one. Now, in your step one class, considering that you're A to B, you'll check A to B first. So, A to B, what will be the value of A to B? That is 0 plus 5. So, it will become 5. 5 is better. So, cancel out the infinite value. So, A to B is done. Let's proceed with A to E. A to E is 0 plus 7, so 7 is better. Then cancel the um, infinite. Then afterwards, proceed with A to F. A to F is 0 plus 6, 6 is better, so it will become 6, and then like this, 0 plus 6, then f will become 6. Okay. Now, afterwards, what will gonna happen? We'll proceed with B to C. What will be the path? I mean, the value of B. B is actually 5 plus the C. This is 13, so therefore there will be 18. So therefore it will become 18. Then cancel the um infinite, since that is the shortest path according to the structures that you do have. Then going to B to F. So you have B 5 and negative 5 as your value. 5 um, plus the negative 5, that it will become 0 because it will be 5 minus 5. So therefore, 0 is better. 6 will be deleted. So F will become 0 and 6 is not good. Um, then afterwards, what will gonna happen? You will be going to go ahead and proceed with C to D. C to D is having 18. Um, so 18 plus the 17, so therefore it will become 35. So 35, cancel that out for D will become 35 and then cancel the infinity. And afterwards, you're done with that. You have to proceed with D to G. So from D, you have 35. 35 plus 15, that's gonna be 50. So therefore, cancel the infinite and G will become 50. Okay. Now, make sure to follow this one accordingly. Okay. E to F. What will be the value of your E? E is 7 plus 2. That is 9. So therefore, we have 0 here. So therefore, 0 is better than 9. So therefore, to become cancelled out. And afterwards, E to H. E to H is 7 plus 3. That is going to be 10. H will become 10. And then we're done with A to H. Let's proceed with F to C. So F is 0 going to C. That's going to be 20. 0 plus 20. So 20. So 18 is better. 20 will we will cancel the 20. Now, we're done with F to C. We'll proceed with F to I. F will be 0. Then going to I is 31. 0 plus 31 will become 31. So therefore no, no, sorry, infinite will be canceled and it will become 31. Now, considering the fact that we're done with F to I, you will go to F to J, to G, J rather. So I'm so sorry, we don't have any F to J, right? That's I to J supposedly. Yeah, we don't have F to J. It will become F to G rather. So let me just, okay, F to G. Okay, that's gonna be okay. So from F you have 0, then going to your G, that is 10. 0 plus 10, 10 is better than 50. So therefore G will become 10 and 50 will be will be removed or will be canceled. Afterwards, you have G to I. Your G is actually 10. Going to I is 10 plus 26. It will become 36. So your I is 31 right now. So you will not begin to take the 36 since 31 is better than 36. Now, after that, you're done with the G to I. You will begin to check right now H to F. So H to F, you have the value of H is 10. Okay, we're not able to update that earlier. So H to F, 10 plus 15, it will become 25. So therefore, you will not accept that one. F will still be 0. Okay, since 25 is not the shortest path. And after that, you will be going to um you will be going to go ahead and make sure to proceed with H to I, considering that H is 10, going to I is 31. So therefore, it will become 10 plus 31, it will become 41. So therefore, um, we'll cancel 41 and it will still be 31 right there, okay? Now we're done with H to I. We'll proceed with H to J. So 10 plus 9, it will become 19. So therefore, cancel infinity, then 19. Okay, then I to J will be 31 plus 1. It will become 32. Then 19 is better than 32. So in your J, it will become 19. Okay, so this is for the first step. So we will be going to check this path accordingly, actually, class, into your step two. In your step two, you will consider um, to check everything. So let's try to update here. 35, 7, 0, 10, 10, 31, and 19. So let's try to check. We'll go over into the list of adjacencies that you do have um, from the beginning here. A to B is still 5, so therefore that's okay. A to E, 0 to 7, that is 7, so therefore good. A to F, 0 plus 7 is still 7, good. Um, A to F rather, 6. So 0 is better. So therefore 0 is optimized. Now, going to B to C, your B right now is 5. Going to C is 13. So 5 plus 13, that's gonna be 18. So 18 is still there. So therefore that's good already. Then B to F, um, from B you have 5 minus 5, so it will become 0 still. So therefore, that's good already. Now, afterwards, you will proceed with C to D. Your C right now is 18, going to D, 17. 17 plus 18, that's gonna be 35. 35 is still there. That has been optimized. And then keep as is. And then we're done with that. D to G. So from D, 35 plus 15. So it will become 50. 50 is not good since 10 is better. So your is optimized already. Then E to F, you have E, 7 plus 2 is 9. 0 is better than 9. So therefore, in your F will become 0 still. Then E to H, your 7 and plus 3 is 10. H is 10 here. So therefore, it has been optimized. F to C, 0 going to C is 20. 0 plus 20, that is C is 18. So 18 is better. So there's no changes. F to I, F is 0, going to I, 0 plus 31. So it is 31 indeed. So I is 31, it has been optimized. F to G, so 0 plus 10, it will become 10. So G is 10 right now. It has been optimized. So there's no significant changes. For G to I, we have G as 10 going to I 26. 10 plus 26, 36. 31 is better. So I is still 31. And H to F, H you have 10 plus F you have 15, 25. So 0 is better, so it has been optimized already, no update. H to I, you have 10 plus 31, 41. So 31 is better, so there's no significant update still. H to J, 10 plus 9, it will become 19, and J is still 19, so there's no changes that will gonna happen. So 31 plus 1 going to J, it will become 32. 19 is better, so therefore there's no significant changes that we will do. This is the Bellman Ford algorithm. So what we're gonna do, since we're able to calculate everything, you have to definitely calculate them all, class. So from 0 plus 5 plus 18 plus 35 plus 7 plus 0 plus 10 plus 10 plus 31 plus 19. It's gonna be 135, the shortest path, accumulated shortest path for all of those things. So thank you so much, everybody. I do hope that you were able to understand how Bellman-Ford algorithm technique work. It's just that you have to be very careful in your implementations. So um, that's the end of our video for the graph data structures, and I do hope that you really learn a lot of informations for graph. Thank you, and see you in our sorting algorithm.